In this video, we're going to be explaining how to solve this problem on graphing quadratics and circles in Algebra 1. The problem statement says, the equation x squared plus 6x plus y squared plus 6y equals 18 represents a circle. What is its center? So before we begin, we're going to start off by looking at a very important formula and format that we can use to solve this kind of problem. So the graph of a quadratic equation doesn't have to be a parabola as discussed in the previous video. It can also be a circle. And there's actually a separate form for the graphs of quadratics that are circles. For reference, this is a very useful form here. The form is actually similar to standard form when graphing linear equations, but a bit more complex. It's derived from the distance formula, which we may discuss in a future video. The form is essentially x minus h squared plus y minus k squared equals r squared. Now there's important things to note here in this form. So we've got our minus h here. So the center of a circle in this form is going to be h comma k. And the signs can be very confusing here. So if you had a circle with center, say, -9 and -9. This would be our center coordinates here. This means that we would have x plus 9 squared and y plus 9 squared. So essentially, we're flipping the sign. If you see a plus h and a plus k, your center is going to be that minus h and minus k. It's a very important sign difference there. Now, the radius of the circle is not important for this problem, but the radius is always going to be equal to r. So if r squared is 49, if we have r is 49 here, that would be a huge radius. That means our radius would just be 49. So that's how you would get the radius and the center of a circle from standard form in that form. So that's very important information to know there. So now that we know the standard form for a quadratic graph of a circle, the radius and the center, we can now begin to solve this question. Now you might be thinking, this craziness here does not look anything like the standard form we just discussed. So yeah, this is a completely different form. This x squared plus 6x stuff. It's off the wall. We need to get it into the correct standard form, otherwise we're not going to be able to do anything here at all. So we need to convert this, and the technique we're going to use to convert this crazy equation into the familiar standard form is completing the square. Now, you probably thought that we were just going to leave completing the square behind when we began to use the quadratic formula, but it's actually still useful here for solving this sort of equation and converting it to the correct form. So, if you look at this closely, you could see we have two binomials here. We've got x squared plus 6x and y squared plus 6y. So those are two binomials there. And we can complete the square on those binomials, find out which constant term we need to tack on to the end of those two binomials to make the entire thing a perfect square. That's essentially the whole concept of the completing the square technique. So we use this technique twice. Let's start with x squared plus 6x. So you might just know that we need to add a 9 here because that completes the binomial of x plus 3 squared. But if you didn't just know that, you could use the formula b over 2 squared, where b is the coefficient of x, in this case 6. So it would be 6 over 2 squared, which is 3 squared, also 9. That's another way to think about it. So that means our completed square equation for this first part is x squared plus 6x plus 9. Then in factored form, binomial form, that is x plus 3 squared. You can expand that, and you'll get x squared plus 6x plus 9. Now, it's the exact same concept for y squared plus 6y. It's literally the same thing, except there's a y instead of an x. So it's literally the same thing. We've got plus 9, and our binomial is going to be y plus 3. Same thing. So those are our two binomials now. We've got this y plus 3 squared and x plus 3 squared. So now we have all the info we need to convert this original insane equation to standard form. Because if you look at this x plus 3 squared over here, this looks familiar when you consider the x minus h squared and the y minus k squared. All we have to do is plug in the values for h and k. So we rewrite our completed equation, and it appears in the form x plus 3 squared plus y plus 3 squared. Okay, so, and that's pretty much all we need to know. We don't even need to deal with the radius or anything like that, because they didn't even ask for it. We can stop right there because we have the values for h and k. That's all we need to know. So we've got plus 3 here and plus 3. Like we said earlier, to find the center of the circle, we need to reverse the sign. So the center of our circle is -3, -3. And that's the answer to this question. So that's how you'd solve a question like this in Algebra 1 when you have to deal with a complex equation you don't know how to solve. You use the standard form principles of the circle graph of a quadratic. You also have to keep in mind that h, k is the center of the circle and the radius equals r. If the equation of the circle isn't already in this standard form here, you usually can use the completing the square technique, provided the quadratic is monic, meaning there's no coefficient of x here. You can use the completing the square technique on these quadratics, on monic quadratics that is, in order to get into standard form and then extract the center of the circle and the radius as needed. Okay, that's pretty much it for how you'd solve this problem on graphing quadratics and circles in Algebra 2.